Okay, so good evening everyone. Good evening to one and all. Give me a confirmation if you guys can hear me. Give me a confirmation if you guys can hear me. Good evening to everyone. Can you guys hear me? Yes or no? Okay. Okay, perfect. So, welcome to the day 3 for this entire workshop of Introduction to Machine Learning. So far, we have understood about machine learning. We have seen machine learning in brief, that what exactly is machine learning and how exactly we have to go on with machine learning, right? We have seen the approaches, we have seen the types of machine learning that we have, and we have seen the certain models that we have currently in the supervised and the under unsupervised. Okay. Now, yesterday we have talked about the theoretical concept of one of a model, right? One of an algorithm, that was a linear regression, right? We have seen how exactly linear regression algorithm predicts and take decision to give us suitable outputs, right? And apart from that, we have also checked out different steps that need to be necessary while following up any machine learning project, right? Today we are going to start with the practical implementation of one of the machine learning algorithm, that is linear regression. Today we are going to see how exactly we have to code. Okay, all the theoretical concept is already done, but now we are going to talk about the practical implementation, how we can start with machine learning on the go. So are you guys ready for that? Yes or no? Please give me a confirmation. Are you guys ready for that? Yes or no? Please give me a confirmation. Okay, perfect. Awesome. So now, first of all, to write a code, you have to need an editor. Okay, you can call this editor as your space where you can write certain piece of code, right? Even though if you want to write any code in Java, C, C++, and different programming languages, you need to have a sheet, right? You need to have a paper to write something on it, right? So similarly, you need to have an editor. Okay, so there are different various editor, various IDE, and various scripts has been available for you. You can download any one of them. Either you can go ahead with PyCharm, or you can go ahead with VS Code, or you can download the Python IDE itself. Okay, so the first step will be that you have to download Python on your system. Okay, so what you need to do is you need to go on Google and search for Python. Okay, the very first link will going to redirect you to the Python home page. Okay, now if you see, there is a download option over here, and this website automatically detects your OS. Okay, so since I am using Mac OS, so it is giving me the suggestion for downloading the Python for Mac OS, and the current version over here is going as Python 3.10.3. Okay, apart from that, if you want to download some other versions, right? If you say that I want to download 3.7 or 3.8, right? So you can click on this link below that states that view the full list of downloads. If you are going to click on that, all the versions that has been released will be given to you, and you can download any one of that. Okay, so this step will be the same for all the OS users. If you are from Windows, you are from Linux, or you are using Mac OS, this step will be a constant part, and this is a step that you can go ahead while working on your local machine. Okay, next thing you need is an editor, okay, or an IDE. Okay, so I suggest you can go with PyCharm. Okay, you can either go with PyCharm, or you can go with VS Code. Okay, so you all are from engineering background, you must be aware about these editors and these IDEs and how exactly we have to use it. Okay, so for Python, PyCharm is a best IDE, because whenever you are working on some kind of softwares, then you can refer to this. Okay, and for the data science part, whenever you are starting working on the analysis and some form of training of a model, so on and so forth, we consider notebooks as the first priority as compared to the IDE. IDEs and source codes are then when you are going to use to implement some softwares. Okay, and on the basis of the data analysis or machine training the machine learning model, we go ahead with notebook. So either you can go ahead with downloading Jupyter notebook, Or the best solution is you can go ahead and check out the free platform that has been given by Google, that is your Google Colab. Okay, so Google provides you this entire notebook at free of cost, so you can make the most out of this. And with this you get 12 GB of RAM as well. Okay, even though if your system doesn't supports 12 GB or 8 GB, or your system has 4 GB of RAM, still you can make the most out of this platform and this opportunity, and you can go ahead to check out Google Colab. So what you need to do is, you don't need to install anything, you just need to search on Google about Google Colab, and that's it. Okay, now you need to hit on the first URL. It will going to redirect you to your Colab notebook page. Okay, so over here you can create multiple notebook. You can see there is an option creating the new notebook, right? As soon as you're going to click on this new notebook, it will automatically going to create you a new interface where you can start your analysis or deployment of not deployment but training of your machine learning models over here, right? Let's understand an overview about this entire interface. First of all, you need to connect to the server, so you need to hit on to the connect button so that it will going to get connected to the Google server. Okay, now you can see it is connecting and it's initializing and allocating you some the memory, right? When it is connected, this option will be shown up over here, RAM and disk. That means Google provides you 12.69 GB of RAM, and apparently it provides you 107 GB of storage. Okay, so that if you want to work on some low level or intermediate level project, you can go ahead with that. Okay, now what you need to do is, you have a lot of cells over here. We call these blocks as the cells. Okay, so you can click on this code. If you it's totally dependent upon you how many cells you want, so you can click on this code and that many cell will be appear over here. Okay, and you can start writing your code over here. Like suppose if we talk about Python, if I want to say print hello world, right? And now I need to hit command and enter, and automatically the piece of code will going to run and I'm going to get an output. Okay, so this is the basic overview about the interface that you that Google provides, that this particular products provides you. And not only that, you can anytime if you want to change your runtime type, that means currently we are using CPU, right? If at some point of time if you're working with deep learning models, right, so in that case you can anytime convert your hardware from CPU to GPU, or even you can go ahead with TPU as well. Okay, till here is it clear to everyone? Till here is it clear to everyone? Yes or no? Till here is it clear to everyone? Yes or no? Come on. Okay, okay, perfect, awesome. Okay, so today we are going to use our Google Colab. Okay, and the next thing that we have to use for the project is a data, right? If you're not having a data, we cannot start doing any kind of machine learning project or data analysis project and so on and so forth. So data is the heart. Okay, so first of all, today what we are going to do is, we are going to take a data set. Okay, so let me provide you the link. So if anyone wants to work along, they can take the reference from this link. Okay, this is our data set. Let me ping this on the chat section. Perfect. Okay, so what you need to do is, it will going to redirect you to a drive link where you need to download this data. Okay, just click on this download button and automatically this data set will going to get downloaded. Now if you're working on your local, you need to put this CSV file into your current directory, or if you're working on Google Colab, then you have to upload this file into your drive link, and you need to connect your drive with the help of your Google Colab, right? And how we are going to connect it, if you see over here, there's a folder icon being given over here, right? You need to click it over here and this icon. Okay, so I have already mount my drive and made a connection between my Google Drive to my Google Colab. Okay, so if you want to do that, connect on this icon and automatically it will going to connect it up. Okay, now you need to search your data set. So let's search on our data set. This is my drive, and let's search for the folder where the data set has been stored. So this is machine learning model deployment and temperature revenue. uh, where is this? Bootcamp 1, yeah, this one. Okay, so in today's session we are going to take a very simple data set. Since there's a time constant, so we are not going to take a raw data set or unclean data set. We have taken a clean data set so that our time will going to get saved. Okay, now the first thing in a data science project is, or in any form of a project, whenever it deals with the data analysis or machine learning or deep learning, is to import all the necessary packages, libraries, modules. Okay, so we are going to import all the necessaries, libraries and packages and modules. Okay, importing all the libraries, modules and packages. Okay, perfect. So if you remember day before yesterday, while I was telling you that if you want to start with machine learning, you need to follow certain steps. You at least know a programming language, then you know about data analysis, and in data analysis you should know about different libraries such as NumPy, Pandas, Matplotlib, Seaborn and RE. Okay, so these are the must libraries that you should use. Okay, and that you should know. So we are going to import these libraries. We use the import function, sorry, import keyword, and then the package or library or module name. Okay, so we are going to use NumPy, and we are going to say NumPy as NP. So over here, this NP is an alias. Alias is a naming convention, because if you see over here, NumPy is of 5 letters, right? So if you have some packages name or modules name or libraries name that are huge, and every time you want to use utilize some functions or some modules or some packages out of that particular library, then you have to write the entire name, right? So to shorten that up, we give a nickname to that, that is known as an alias. And over here we are saying that we are going to call NumPy as NP. Okay, similarly we are going to import another library known as Pandas, and Pandas is used for data manipulation, data cleaning and data exploration, and a little bit part of Pandas can also be used for the data visualization as well. Okay, now we are going to import Matplotlib, because Matplotlib will going to help us to work on the visualization of the data. Okay, so we are going to import it from pyplot as plt, and next is your Seaborn as SNS. Now we are going to import RE. RE is very important because it helps you to do the data cleaning. Okay, so the full form of RE is your regex. So over here you make a regex so that you can easily apply that regex in the humongous data, and within a fraction of a second and writing just a piece of code, you can clean a humongous data as well. Okay, till here is it clear to everyone? Yes or no? Till here is it clear to everyone? Yes or no? Please give me a confirmation. Okay, perfect. Now these are the libraries that will going to help us to do all the data analysis part. That means data exploration, data cleaning, data visualization, data manipulation. Okay, now we are talking about machine learning. Okay, so the libraries that we are going to use is your sklearn. Okay, and we are going to put out some interesting function from sklearn that will going to help us in making the entire project. Okay, so we are going to use from sklearn, we are first going to import our model. Today we are going to talk about the linear regression, right? So from linear model, linear underscore model, we are going to import linear regression. Okay, so linear regression is very important because this is our model. Okay, after that we need to have a train test split function, because train test split function helps us to divide the entire data in two parts. One is the training part and another is the testing part. Okay, so we are going to use sklearn and model selection. We are going to import train test split. Okay, now the last thing that we need to have is a metric. Okay, we have to have a metric because that will going to help us to find out the accuracy, right? So we have to have an idea that how accurate our model is and what is the all the prediction that our model make, how how nearer it is to the actual value. Okay, so we are going to use a matrix. So we are going to say from sklearn dot matrices import r square. Okay, so you can have any matrices such as you can have RMSC, you can have MSC, you can have MAE, anything, right? So we are going to use r square from here. Okay, so let's run this. What's the difference? No module as, oh, just a second, from sklearn dot matrices, just a second, it should be without this. Perfect. So now all the importation of the libraries and modules has been done. Okay, the next part is to bring out the data set so that we can start working on the data set. Okay, so for that we are going to use the help of pandas library to bring our data set. Okay, so currently my data set has been uploaded on Google Drive, right? So now I want to bring this data from here to here. Okay, so for that I'm going to create an object, a df, and over here I'm going to use pd.pandas, not pd.pandas, pd.read underscore csv, because if you see the format of this file, if you see the format of this file, it is a csv file, right? We have to read a csv file. If this file is an excel file, then we will going to use a read underscore excel file, or if it is a json file, then we are going to use read underscore json file. So let me show you what possible functions you have. Read underscore, you can see these are all the functions that will going to support the file. So suppose you are having a data in a file of a csv, you can, then you have to use the function read underscore csv. If you have data in a form of excel file, then you have to use read underscore excel file. If you have a data, you can say in html format, then you have to use read underscore html, and similarly json, pickle, and so on and so forth, right? So in our case we have to go with the csv file, because our file, the data that we have been given is a csv file. Okay, so now we have to mention the location, the entire path where the file has been located. Okay, so I'm going to click on this folder icon and we're going to locate where is my file. So over here, this is our file, that is your ice cream data, right? So I'm going to click on this hamburger menu and copy the path, and that's it. Let's paste this over here and let's run this. Now what has happened is that we have brought the entire data, and this entire data has been stored inside this variable known as df. Okay, now if you want to check for the df, if I say df, you will going to see a table will be given to us. See, this is a table, this is exactly the same table that has been given over here. Yes or no? And we have two columns, the one is being temperature and another being is the revenue, right? And if you see, there's a lot of multiple datas over here. Till here, is it clear to everyone? Till here, is it clear to everyone? Yes or no? Till here, is it clear to everyone? Yes or no? Okay, perfect. Now see over here. So this entire data has been stored in the variable df. Okay, now if you want to check out only the first 5 rows, if you say that whenever we are calling this df, all the data point has been appearing over here, right? So it doesn't looks good. So what we are going to do is, if you want to see only the top 5 rows, we have a function known as a head function. This head function says that if you are giving an argument, then it will going to show that many numbers of rows. Otherwise, by default, the value has been set to 5. That means if you are not giving any argument, what will going to happen? It will going to show you the top 5 rows. Okay, so let's run this. Now if we see, top 5 data points has been appeared over here. Okay, now if you say that I want to check top 10 data points, so what you need to do is you need to pass the argument into this head function as 10, and now if you see, we are getting all the 10 data points starting from the top. Okay, similarly we have a tail function. Tail function says that it will going to show all the data from bottom. okay, and by default the default value has been set to 5. Okay, so if we say df.tail and we don't pass any argument, we will be getting the bottom 5 data. Okay, let's see this. You can see this is the bottom 5 data point has been appeared over here. And now if you say that I want to see the bottom 10 data or bottom 15 data, then you need to pass an argument. Let's say you want to see bottom 15 data. So these are all the 15 data starting from the bottom. Okay, so these are the two functions, that is your head function, the tail function, and it is associated with pandas. Okay, now if you want to check how many numbers of columns are there, or if you want to check how many rows are there and how many columns are there, right? So we have an attribute known as a shape attribute. So what this shape will going to do, this shape will going to tell you how many rows are there and how many columns are there. So there are 500 rows and 2 columns. Okay, even though if you check over here, there are 2 columns, that is your temperature and revenue, and there are 500 rows, the last being having the index value as 499. That doesn't mean that we have 499 values, right? Because in Python indexing starts from 0, right? So that's why we have to count that as well. So in a nutshell, we have 500 rows and 2 columns. Okay, now if you want to check the dimension, of your data set, it's a 2 dimension because it has 2 axes, right? One as the y axis and another being as the x axis, right? So if you want to check that, we have another attribute that is known as ndim. Okay, this will going to tell you how many dimensions are there, and it shows there are 2 dimensions, right? That means rows and columns are the 2 dimension. Okay, now if you want to check out all the column names, currently we only have 2 columns, temperature and revenue, right? But generally when you are working with a humongous data set, you get multiple columns. Okay, that also sometimes results into occurring into the curse of dimensionality as well. Okay, so if you want to check that how many columns are there, then you have to use the attribute columns. Okay, so you are going to use columns, and now all the columns will be presented to you in a form of a list. So now if you see over here, this is your entire list, and this list contain all the column name, that is your temperature, and this is your revenue. Till here is it clear? Yes or no? Till here is it clear? Yes or no? Come on. Perfect. Awesome. Okay, now there are 2 more functions. One is your describe function and another being is your info function. Okay, info function will going to give you a basic information about the entire data set, that how many entries are there, and at the same time it is very important because with the help of the information function we can find out that whether there is any null value exist or not. Okay, if it does, we have to clean that null value before going on to the machine learning part. Okay, so let's see how exactly we can use the info function. So the same way, df, that is our data set, and we are going to use this info function. Now what will going to happen, it will going to show us a basic information, and information says that there are 500 entries. That means there are 500 data points that are starting from 0 to 499. That is a range that has been given to you, right? And again it has been shown the column over here. We have 2 columns. First column is temperature and the column is revenue, right? And then in the next column it shows a not null value, non-null value, and it is very important because this is the first step to detect whether a column contains any null value or not. Okay, or you can also check that with the help of isNull function, but this is the first step to check. Okay, now if you see, it says that 500 non-null values, that means there are no null values that exist currently, because at starting as well I have already told you that this is a clean data. Okay, we have taken a clean data to save the time. Okay, otherwise if we have taken the raw data, it would have taken a couple of hours to just clean the data, right? And if you see the d type is your data type. That means all the data that has been stored into this column, what exactly is the type of those data, right? If you see over here, this data, if suppose 34.47 so on and so forth, it is in a floating value, right? This is a floating value, right? So that means all the data that has been given, the data type is a floating value. We have integer, float, we have string, we have boolean, we have complex, and we have so on and so forth, right? So similarly it shows that what exactly is the d type of the data that has been contained into the column of temperature and revenue as well. Okay, Till here is it clear? And it also shows you that how many memories it has been using, right? It is 7.9 KB. Now the next function is your describe function. Now we use a describe function when you want to know the statistical information about the data set. Statistical information about the data set means when you want to find out what is the maximum value, what is the minimum value, what is the mean, median, mode, upper quartile, lower quartile, and so on and so forth, right? So let's run this up. And if you see, this is the first column, that is temperature, this is the second column, that is your revenue, and these are some of the statistical information, that how many values are there. There are 500 values. What is the mean value or the average values? That is your 22 point something. What is the standard deviation, and what is the minimum value over here, and what is the maximum value? And then we have 25%, 50% and 75%. These are the quartiles. Okay, this is your inner quartile and this is your outer quartile, and this is your mid quartile. But this 50% is also known as a median value. Okay, so this all been related with the statistics. If you know statistics, it will be very easy for you to understand about the quartiles and how quartiles helps us. Understanding the concept of quartiles really helps us to overcome with the outliers. Okay, so outliers is just an advanced concept which we will going to discuss in some other other session. Okay, till here is it clear? Yes or no? Till here is it clear? Yes or no? Okay, come on, tell me, is it clear? Perfect. Now the second method, this was the first method to check whether any null data exists in a column or not. What is the second data? The second data is that you can use a function is null. Okay, so you need to first declare the data set, that is your df, then you need to use the function as is null. Okay, now is null will going to return you a boolean value, right? Boolean means it has two values, that is true and false, on or off, 0 and 1, right? And it could have only one value at a time. So when we are using is null, it will going to state whether the value is null or not. So it will going to result in giving us all the options in a form of true and false. If you are going to run this up, you can see we have two columns, that is your temperature and revenue, and now it is checking whether this value is null or not. Obviously we have a value as where is the data set? We have the value as 24.5, right? Which is obviously not null, right? Which is obviously not null, right? So over here it will going to state that false. It is absolutely false because this value is not null, right? But the another way is to check that if it is looking very ugly, like how we can find out wherever there is true, right? So you can use a sum function, and with the help of sum function it will going to tell you that the total number of null value that exists in a particular column, right? So it shows that 0 and 0, that means there are 0 null values that is present in temperature. That means we don't have any null value currently in our data set. Okay, till here is it clear? Now let's move on to the next part, to our data set. So now let me print the head. Now if you see in this data set, we have two column. Okay, now where exactly is this data set is coming from? This data set is being coming from an ice cream shop. Okay, so an ice cream shop owner has marked the data for the entire year, and they have sold the ice cream into different temperature. Okay, and they have marked the revenue, and what was the revenue when the temperature was was high or low, and so on and so forth. So it says that when the temperature was about like 24.5 degrees Celsius, the revenue that they have generated was 534. So it might be $534 or $534K, so on and so forth. We assume that everything is in a form of a K or $1,000. Okay, so we know there's a relationship between the temperature and revenue. That means as the temperature will going to decrease, right, as the temperature will going to decrease, obviously people will not choose to have ice cream, right? Very less people will going to opt to go for ice cream. That means automatically revenue will going to decrease, right? And as the temperature will increase, obviously people will going to purchase more ice cream as usual, right? And it will going to affect in the in the revenue, and so the revenue will also going to increase. So the relationship between these two, we can suggest it's a directly proportional, and it is known as a covariance. Covariance will going to give you a direction, okay, and correlation will going to give you a direction along with the value of the relationship. Okay, so I can say that temperature and revenue are directly proportional to each other. That means as the temperature rises, revenue also rises. As the temperature decreases, revenue also decreases. Yes or no? Can I say that? Can I say that? Yes or no? Come on, come on, come on, tell me. Okay, perfect. So now this is just an assumption over here, right? We haven't performed any analysis. This is just an assumption that we are taking, right? Now we have to prove our assumption that this is actually a case, that when the temperature increases, the revenue also increases, right? We have using a simple logic form over here, that we have an ice cream shop. Ice cream shop is selling some different flavors of ice cream, and they are giving a data set to showcase their revenue that are based on the different temperatures, right? And we say that ice cream is only been sold or mostly been sold during the time when when the temperature is mostly high, right? Even though when the temperature is low, some people prefer to have ice cream, but not everyone, right? So the obviously it will going to affect the revenue. So we can make a logic that as the temperature increases, revenue also increases, and as the temperature decreases, revenue also decreases. Are you guys clear till here? Are you guys clear till here? Yes or no? Come on. Okay, now let's see how we can visually see what exactly is this data. Right now we are going to use a scatter plot. Scatter plot is very important because it will going to help us to show the relationship. Okay, it will going to show us the direction of the relationship, what exactly is the relationship between these two. So we are going to use a scatter plot, and that will going to come from matplotlib pyplot. Okay, so we are going to use scatter, and on the x-axis we are going to put temperature, that is your df dot temperature, and on the y-axis we are going to have revenue. Okay, and one more thing before going forward, if you see, we have two columns, right? We have two columns, and over here revenue is dependent upon temperature. Revenue is dependent upon temperature, right? Temperature is not dependent upon revenue. Over here temperature is not dependent upon revenue. Like suppose if you say the ice cream shop has created a generated a revenue of $625K, it doesn't mean that temperature should be 26. It might happen the temperature might be at 1 degree Celsius, it might be 36 degrees Celsius, right? So temperature is absolutely independent, whereas revenue over here is dependent on temperature. That means if revenue is dependent, then definitely revenue is a target variable and the rest is your feature. So over here we have a temperature as a feature and we have a revenue as a target variable. Okay, that means we have to predict revenue. We have to predict revenue. We will going to take the temperature from the user and we are going to predict what will be the revenue if the temperature is this many degrees of Celsius, right? And which type of linear regression is this? Can you guys suggest me? Which type of linear regression is this? We have one feature and we have one target variable. So which type of linear regression is this? We have discussed about three types of linear regression, right? Single linear regression, multiple linear regression, and polynomial linear regression. So which type of the linear regression do you think it is? Is it single, is it multiple, or is it a polynomial linear regression? Come on, come on, come on, come on, let's see who will going to get it right. Is it single linear regression or a multiple linear regression, or it is a polynomial linear regression? Okay, so it's a single linear regression, right? Because we have only one feature and we have only one target variable, right? It will be a multiple linear regression when we have more than one feature and we have one target variable, right? So over here we have the temperature and we have revenue, and we will going to predict the revenue on the basis of temperature. So if you remember yesterday we have seen the linear regression formula, that is y is equals to mx plus c, right? Where your m over here is your slope, but we call this m as a regression coefficient, and over here c is your slope. Okay, and this c has been found out with the help of gradient descent. Okay, with the help of gradient descent we find out the intercept. Okay, now if you want to modify this, you can modify over here that revenue equals to m into temperature plus your intercept, that is your c. This is your formula that will be created on the basis of this data. Okay, so now we are going to use the scatter plot to see the relationship between these two data. Let's see this. Now see over here, can you see this line? It is forming a linear line, yes or no? Let me copy this and paste it over here. Let's paste this over here. Perfect. Now see this data. On the x-axis we have your temperature, right? And on your y-axis we have our revenue. And if you see the line, it is going linearly. That means as the temperature is increasing, so does the revenue as well, right? As the temperature is increasing, and the revenue is also increasing at the same time. That means there is a relation between these two. And this direction is known as a covariance. Covariance always tell you the relationship direction, whether it's a positive direction or a negative direction. Okay, if you want to find out the value or the strength of the relationship, you have to use the regression correlation. Okay, so now what we are going to do is, we know that there is a relation, we are sure. Let me make it more clear as plt dot x label. Okay, on x-axis we have our temperature, and on y-axis we have our revenue. Okay, and let me give this as a title as well, plt dot title, and the title is your temperature versus, it's not temperature, it's temperature versus revenue. Okay, now if you see, now it's looking good, right? So on my x-axis we have temperature, on my y-axis we have revenue, and this is the graph of temperature versus revenue, right? So over here we can only see the direction, that there is a positive direction. As the temperature is increasing, so does your revenue. But I want to find out the value. I want to find out that what exactly is the strength of the relationship, right? How much you are confident that they both are directly proportional to each other. For this we are going to use correlation. Okay, so we have a function to find a correlation. So we are going to say df dot correlation, corr, and that's it. Okay, now it will going to tell us the strength. If you see, the correlation is 98.9. that means 0.989 means 98.9%, and if you round this off, 99% of correlation you are getting. You guys are getting 99% correlation. That means the relationship value they both share is your 99%, right? And 99% is approximately 1, and it has been called as a strong positive correlation. That means revenue depends upon temperature, and what is the strength of the dependence? It is 99%, and this is very, very high, right? And if you want to visualize this data, instead of placing it in this form, you can also use a heat map to perform this. Okay, if you want to visualize this data, you can perform the heat map to perform this. So let's say sns.heatmap, and we are going to put df.core, and apart from that we are going to say not is equals to true, annotation. So all the values will be shown, and we are going to say cmap, that is your color, it will be greens. Okay, perfect. So let's run this. Green is okay, it should be green, it should be capital G. Yeah, now it will going to work. Perfect. Now if we see, this is your visualization. Over here you can see temperature and revenue, and temperature and revenue. So a variable, a relationship between a variable to itself will always be 1 only, right? If you see the relationship of temperature with respect to temperature, it will always be 1. If you see the relationship between revenue to its revenue, it will always be 1, right? So if you see that relationship between the temperature and revenue, it is going to give you is 0.99. that means your regression is your correlation is your 99. Okay, 99% is your correlation. Now what you will going to do is, now you are done with all the analysis, exploration and everything. Now we are going to jump towards the machine learning part. Are you guys ready for this? Are you guys ready for this? Yes or no? Come on. Are you guys ready for this? Yes or no? Perfect. So now what we are going to do is, we have to follow the steps. We have to follow the steps that we have seen yesterday. Let's go on to this. Now this is the steps. Okay. First step is get the data, which is already done, right? Data analysis, it is already done, right? Data exploration is done. Manipulation and cleaning we haven't used because the data was already cleaned, right? Visualization we have done, right? Next is feature and target. You have to separate, you have to create a two separate variable. One variable will going to contain all the features and other variable will going to contain your target variable, right? So now we are going to say x is equals to df dot temperature. That means we are storing the data of temperature to the variable x. Okay. Similarly on y we are going to say df dot revenue, because revenue over here is your target variable. That means we have to predict revenue. So let's run this. Now if you see, earlier the data set was having a dimension as 2, right? Whenever you are using any model from scalar or train test plate, it always says that your feature should be having the 2 dimension. It should be having a dimension of 2, right? But now if you are going to check x, we are going to find it is of 1 dimension. See this, it is of 1 dimension. So what we need to do is, we need to convert our data from 1 dimension to 2 dimension. Now see how exactly our data looks in 1D. This is your 1D data. See, this is your 1 dimensional data, right? Now we have to convert this data into a 2 dimensional data, because feature should always be into form of 2 dimensional. Okay, so now what we are going to do is, we are going to use a reassignment where we are going to say x is equals to x dot values, and we are going to use a reshape function -1 and 1. This -1 means that the total number of values that you are having, in x. If you know that, which already is 500, that we know, you can also provide 500. If in case you don't know about that, you can simply write it -1, so machine or interpreter will automatically going to detect that. Okay, now let's run this. So now earlier the dimension was 1, right? But now if you are going to check the dimension, it will going to be become as 2. Now see this, and let's see how exactly the data looks in a form of 2 dimensional. Now see, this is your 1 dimensional data and this is your 2 dimensional data. Okay, more clearance about 1D and 2D, what exactly is 1 dimensional data and 2 dimensional data, will be clear from NumPy and pandas. Whenever you start with NumPy and pandas, then you will get to know what is a 1 dimensional data, 2 dimensional data, what is the other dimensional data, that is your n into n dimensional data. Okay, so now we have converted into 2 dimensional data. So this is also done. Next part is, you need to split the data set into 2 parts, that is your training set and your testing set. Okay, so we are going to use the train test plate to convert the data into 2 parts, that is your training set and testing set. Okay, so we are going to say, we are going to create x underscore train. This is your training data set. That means we are going to divide it. Okay, so how exactly our data set will going to look like? So suppose this is our data set, right? In this data set we have 2 columns, right? In this data set we have 2 columns. This is your first column, which is your x, right? And this is your second column, which is your y. Okay, till here it's clear. We have done that. We have provided all the temperature data to x and we have provided all the revenue data to y, right? Now what we need to do is, we need to divide this data into 2 parts, one for the training phase and another for the testing phase, right? So now we are going to divide this into 2 parts, right? So now if you see, these are the true parts. Over here the first part will be your training part and the next part will be your testing part, right? So apparently this portion will going to become, this is your x underscore, and this is your train, so it will become x train, right? Similarly over here this is your y, so it will go into y underscore, and this is your train, it is a y train. Okay, now over here this is your x underscore, this is your test, this is your x underscore test, and then we have y underscore test. Okay, so we have to store these many data into these variables. So we have to store this portion of data into the variable x train. We have to store this portion of data into y train. We have to store this portion of data into x test, and lastly we have to store this portion of data into y test. Okay, so we are going to say x train, x underscore test, y underscore train, y underscore test. Okay, so we have created four variable. We have created four variable: x train, x test, y train, y test, as mentioned over here. Is it clear? Is it clear? Yes or no? Perfect. Now what we are going to do is we are going to use a train test split, train underscore test underscore split. And now in this train test underscore we have to provide the data. Okay, the first the features, and another is your target variable, right? So the features is been contained in x, and the label and the target variable is been contained on y, right? Now the next is your test size. Test size means that how much size do you want for testing, how much portion of the data do you want for the testing phase, right? We generally take the 80 to 20 ratio. We generally take the 80 to 20 ratio for the train test split. That means 80% of data will be dedicated for the training phase, and 20% of data will be dedicated for your testing phase. Okay, so we are going to use this. So we are going to use 20% of our testing data set. So we are going to say that we want 20%. So we are going to say 0.2. Okay, so apparently 0.8 will be dedicated to your training set. Okay, so let's run this. Now if you see x underscore train dot shape, right? Now if you see the number of rows that we have, it is 400. That means earlier we were having 500 data points, and from this 500 data point we have split the data into 80 to 20 ratio. That means 80% of 500 is your 400, and 20% of your 500 is your 100. That means 400 data point is being given to your training data set, and 100 data point has been given to your testing data set. Okay, let's check this out as well. X underscore test dot shape, you will going to see 100 data points will be dedicated to x test. Okay, so if you say 400 plus 100 is equals to 500. Okay, so till here you have splitted all the data set, and when you are training the model you will going to give your training data set. That means x train and y train will be given during the training phase, and when you want to predict the model, x test will be given, x underscore test will be given. This is your actual value, and when you give this x underscore test to your model will going to give you a value, and that value means as a predicted value. Now you will going to compare that predicted value to your actual value to find out how accurate our model is. Is this clear to everyone? Is this clear to everyone? Yes or no? Okay, perfect. Now let's move on. Now we need to initialize the object of our model. Okay, now we need to initialize the object of our model. So we are going to say model. Okay, and we are going to say linear regression. So now linear regression. So now the linear regression model has been initialized, and we have the object of linear regression model in this model variable. Okay, now we are going to say model dot fit. Model dot fit means the training phase. Now from here the training phase starts. Okay, so we are going to use model dot fit, and we have to give the training data set. So training data set is x underscore train and y underscore train. These are the training data set. Yes or no? Over here these are the training data set. So we have to give x train and y train, right? Training data set is equals to x train plus y train. So over here we are providing x train and y train. Okay, currently we are not going deeper into this concept. That means we are not discussing about the hyperparameter tuning. They are the advanced concept. Okay, so let's run this, and a model has been trained. Now see, it is very simple, it is very fast. Linear regression is simple and fast as well, and although we have a very short amount of data as well. Now the training part has been done, so my model is been trained. Now we need to test our model as well. We have to check whether model has been trained or not. But before that, if you remember this equation, y is equals to mx plus c, if you remember, right? So now what is the value of m and what is the value of c that our model has determined, right? If you want to check this, you have to use a model dot coefficient, that will going to give you the coefficient value, that is your m value. Okay, let's see this. This is your m value, that is your correlation coefficient value. Okay, and if you want to check for the intercept, you can use intercept underscore, and this is your intercept value. Now if you put all these value into this equation, it will going to become revenue equals to your coefficient, that is your m. Okay, let me copy this, into temperature plus your c, that is your intercept. This is your intercept, right? Let me paste this, your intercept. Now this is your value. Now this is your entire equation. Now you will going to take the temperature from user and you can easily predict out the revenue. Let's say the temperature, let's use this entire formula to do that. Okay, let's use this entire formula to see what will be the prediction. Okay, let's copy this and paste this up. Let's say temperature is 40 degrees. So what do you think? Will the attendance, will the revenue be higher or not? If temperature is 40 degree, will the revenue be higher or it will be lesser? Come on. If we take temperature as 40 degree and we want to find out what will be the revenue of that ice cream shop if the temperature is 40 degrees Celsius. So what do you think? The temperature will be higher or the revenue will be higher or lesser? Since temperature and revenues are directly proportional, so as the temperature increases, the revenue also increases, and 40 is a higher value. That means revenue will also going to increase. Yes or no? So if we replace this temperature with 40, let's see what revenue we get. We get $902K, which is absolutely high. Yes or no? Let's see what will going to happen if our temperature becomes 1, right? So will revenue will going to decrease? Yes, it does. Now see, as the temperature increases, your revenue increases. As the temperature decreases, your revenue also decreases, right? So by this you can check this up. Okay, this is the formula that linear regression takes to check how exactly how to predict out the value of revenue, right? Now what we are going to do is, over here we have fitted the model. Now we have to test our model, right? So now we are going to move towards the training phase. Over here we are going to say model.predict x underscore test, and this will going to give us y underscore predict. Okay, let me save it into a variable y underscore predict. Okay, so now I have y underscore test, that is your actual value with relation to this data, and we have y underscore predict, that is your predicted value. Okay, this is your predicted value. Now it is very difficult to compare these two values. So what we are going to do is we are going to create a new data frame. Where is this? Yeah, we are going to create a new data frame, pd dot data frame. Okay, and this data frame we are going to say actual value. Actual value will be your y underscore test. Okay, and then we have the predicted value, which we have your y underscore predicted. Let's run this. Let's add some more codes. Perfect. So now a new data set has been created so that we can easily compare the the actual value with the predicted value. Okay, so now if we say new df dot head, so now see this. This is your actual value and this is your predicted value. That means on the basis of the x, that is your temperature that is been contained on x underscore test, right? Actual value was 598, but our predicted value is 576. If you see, our model has predicted way more nearer to the actual value, right? Over here as well, the actual value is 682 and our model has predicted 676, which is absolutely nearer to our actual value, right? So more the predicted value nearer to the actual value, higher will be the accuracy as well. Okay, so you need to make sure as the error decreases, accuracy automatically increases. Okay, now the last thing is to determine what is the, if you want to plot this on a scatter plot, if you say that I want to look on how exactly these two data looks like, right? So what you can say, plt.scatter. Now over here, x underscore test, y underscore test, and let me give this color as blue so that we can differentiate between these two color. Okay, let me copy this and paste it over here, and instead of this y test we are going to say y predict, and let's give the color to red. Now this is our scatter plot graph of both actual value and predicted value. Now see, all the values, all the points that are in blue, right, they are the actual value, and all the points that are in on the red, right, they are being marked in red, they are the predicted values, right? So with the help of this we can see there's a huge relational between these two variable, that is a temperature and revenue, right? Now the last thing is to check the accuracy. Last thing is to check the accuracy. Okay, because we have to check that how much accurate our model is. If I give our model like 48, if I say the temperature is 48, so the result that our model is going to provide us, how much accurate is it? Is it 10% accurate, is 14% accurate, it is 50% accurate, 90% accurate, and how many percent of accuracy are there? So we are going to use r square score, and over here we are going to say y underscore test comma y underscore pred. That means this is your actual value and this is a predicted value. With the help of these two, it will going to find out all the errors and it will going to perform the operation to find out the accuracy. Let's see. Our accuracy is 0.98. That means this is approximately 99% of accuracy, or you can call this as 98.6, which is approximately 99% of accuracy. So you can see your model is way more accurate, right? So if you are predicting the revenue by giving some temperature, there are 99% of chance that your value will be nearer to your actual value. Till here is it clear? Till here is it clear? Yes or no? Okay, and if you want to check the prediction of your model on your custom input, you can do that as well. You can say model dot predict, and now you say that I want to check for the temperature, let's say 70. So let's check this. When the temperature is 70, your revenue is this $1545K. Okay, so this how you define the entire machine learning project. In this project we have learned a lot of things about how the data set looks like, how we have to bring the data set onto our canvas, and how we have to perform the data analysis, how we have to split the data set into two parts, and we have to split the data set from features and the target variable basis. We have to define the object of our model, then we have to go with the training phase, then we have to perform some operation, then we have to move on some testing phase, and at last we have to have an accuracy, and if you see we are getting a higher accuracy over here. So this was just a short project to tell you about how exactly machine learning works and how interesting machine learning is. Okay, so I will be sharing you this entire Colab link with you. Okay, and this Colab link will be containing 3 links. One is your dataset link. If you want to work on this project, you can click on this dataset and you can start working on that. If you want the Jamboard link, the PPTs and all that we have worked during this entire 3 days, you can collect it from here, and the attendance link for the 3rd day is also been provided over here. Okay, so let me provide the 3rd day attendance link, and this how we wrap up the entire 3-day session and 3-day workshop for introduction to machine learning. I believe it was an interesting session and you guys have gained a lot of knowledge, and I believe that it also excites you all to go furthermore to discover more about machine learning. This is just the starting. This is not even the 1% of machine learning. Machine learning is very very interesting, and with the help of that you can create a lot of models. You can integrate it into various softwares. You can use a time series analysis to predict out the stock prices, how whether the stock will going to rise or it will going to decline, what will going to happen in the upcoming time, and so on and so forth. You can do a lot of more prediction based on the data, right? And the next question arises is where you will going to find the data. If I want to start with machine learning project or model, I need to have a data. Where can I find the data? The best place to find a data is on Kaggle. Okay, so there's a website, Kaggle. So what you need to do is you have to search on Google. So you have to search on Google about Kaggle. Kaggle is being acquired by Google itself. Okay, so over here you need to click on Kaggle, and you can find out any kind of data set. Any kind of data set, you just need to create an account, and over here you can see the data set over here, right? Click on the data set and it will going to show you humongous amount of data set, and you can evenly search for the data set that you want. If you're searching for a car data set, stock data set, or you are searching for COVID data set, and so on and so forth, right? So you can look on to this website and you can get any data set and you can start your machine learning journey as well. Okay, so is this clear to all of you? Perfect. So this is your link for your Jamboard, sorry, for the Google Colab, and this link contains all the other 3 URLs and links, so you can take the reference from that. Okay, so link has been pinged. Let me do it again and ping the link, and let's ping it again. Perfect. And that's how we have wrapped up the entire 3-day session. If you have any doubts regarding the session, please ask. If you have any doubts, please send your question on the chat section. Do you guys have any doubt? Yes or no? Okay, and apart from that, if you are more interested in different courses, right? If you want to check out some different courses, you can go on and check out the DevTown website. We do have really exciting courses and batches coming up. Let me show you devtown.in. Sorry, that is doing DevTown, and here you go. Okay, so if you're more interested in the field of data science, or you want to create some websites and APIs and all that, we have 2 courses. We have launched 2 courses, one being for the full stack courses and another being as a data science industrial training program courses. Okay, you can give it a thought. You can look on to what all the subject has been taught, and the best part is that there are all the instructor that will going to teach you are from higher very reputed organization. If you see, we are having people from TensorFlow, Morgan Stanley, McKinsey, and Goldman Sachs, and all that. Okay, so if you want to join it, if you have an urge to start on and learn something new, you can give this a shot, and over here you can download the syllabus. You can check out the syllabus, what all you will going to learn and what is the duration. The duration is of 2.5 to 3 months, and these are some of the projects that you can expect to be that we will be going to create during the entire session. These are some of the technologies that you will going to get masters on, and the next upcoming batch will going to start from March 21st. Okay, so if you have any doubts or any query, you can contact to the team, and team will surely going to help you out regarding this. Okay, let me ping up this link over here as well. Perfect. So certificate for this will be given to you by the team. Okay, now team will going to review all the responses, and they will going to get back to you within a week, and you will be getting all your certificates with on your inbox. Okay, So that's all from my end. Thank you so much for joining the session. See you all in the upcoming session as well. Till then, have a great time. Happy Holi to everyone and take care. Thank you so much for joining in. See you all later. Thank you.